In this video, we're going to discuss UML class diagrams. So this is our presentation. And so basically the idea of UML class diagram that we create is that we give the name of the class in the upper box of the class diagram. It's just basically a box that represents a single class. And we specify a set of values, a set of data types associated with these values, and these will create the data attributes. So the values as attributes could be private, what we call friendly, and public. So essentially, when we have an example of a class like this, so typically in a programming language we use class keyword to give class the name, and the class body is typically enclosed in these opening and closing braces, and the private value, basically encapsulated value, which is not visible outside of this class, only within this class it becomes available. We use the private keyword. The friendly value can be shared in Java with the package. So within a single package of classes, you can share values that don't have private or public keyword. And public data attributes are discouraged. Typically only constant public data attributes should be acceptable in proper design according to the rules of encapsulation. But of course the keyword public can be used with data members just as with methods and operations inside the class. So this is Java example. There are also utility classes. Utility classes typically are designed not to contain any description of objects that should be instantiated. Rather, they just collection of utility operations such as, for instance, sorting, searching, and other types of algorithms that can be applied without any need for object to be instantiated of this class. So such classes normally referred to as utility classes by their design. So utility class will have only static methods. Method is of course the name of the operation in Java. No data members, so that utility class does not rely on instance variable that typically are found inside objects, and no other non-static methods. Just basically a collection of static methods, which are just methods that don't belong to any objects, and these represent operations such as searching and sorting inside collections of classes, for example. The classes can be parameterized by other classes. So this is a feature typically referred to as generic programming. So in generic programming environments such as Java and C++, what we can do is we can start this example like create a class diagram and create a class that is called a list. Okay, so here we can create a class that's called list. Okay, so list is a class and we define it like this. Okay, so this is one of the classes that we define. However, list can be a list of various types. For example, we can have a list of flight objects, or we can have a list of confirmed reservations. We can have a list of integers. So there could be different kinds of lists. So to specify a list that we can use in our application as a final parameterized class type, we typically, in diagramming, we combine those generic classes such as list of items with, for instance, list of flight object, right? So flight objects can be put on the list. So this is a combination that we create like this. and I don't know if I can bring this up, but apparently not, but you get the idea. So basically we combine the boxes, and so list of flights is specified as a combination, but the flight should be on top of it. So basically we need to flip the descriptions here. If I make this a flight, right, and if I make this a list, then parameterized list by flight will look like this. Okay, and the next time I can actually take these two objects and copy and paste them like this, and the idea of parameterization, and now I can have a list for instance of reservations, right? A list of confirmed reservations. So if confirmed reservation is an object in our system, then we can do this. We can just change this to confirmed reservation. Okay, and so we can combine confirmed reservation with list like this. Again, I don't know why, but I need to bring this to the top. And if we combine list with confirmed reservation, we have a list of confirmed reservations. So in other words, parameterized classes are basically combination of generic class, which is expecting to be supplied with some other type of data, another class, which can be used internally to organize internal data structures of the list with respect to a list of flights or a list of confirmed reservations. Okay, so that's the idea of parameterized class, and this is how they look like typically during the design. Again, I would have to change this to something that looks like this to make it proper UML, right? So this was a list, and now it's just that the overlap should go like this. Then we have a proper UML arrangement of a list of confirmed reservations and a list of flights. And this can go on, right? So we can create list of integers. It doesn't matter. As long as we have some sort of object, we can put it on a list and have it organized as a list, parameterized by specific data type. So in terms of syntax, parameterized classes in C++ typically use template keyword, and generic programming is relying on template functions and template classes in C++. So Java doesn't have templates. Java has generics, which were added in early 2000s to the Java programming language, and many of you are familiar with Java collections such as array list or hash map. These are parameterized classes in Java, and they're called Java generic containers. So this is the syntax. So in UML we use combination of boxes. Here we use typically we just specify generic parameters right here, like for instance class flight or class confirm reservation, and this would be our list, right? So this would be the list class. So then we, inside this code, we can use these generic data types provided when we combine list with its type parameter. So then these flights and confirmed reservations can be generically used inside the implementation of the parameterized class. Utility classes can also be parameterized. It doesn't matter. You just get some kind of type that you can use inside this parameterized class generically internally in its implementation. So once again, it's the same syntax, and again, as with previously discussed utility classes, only static methods should be used inside the implementation of utility class. By the way, there's a bit of a syntax error. If this is an example of C++ using templates, then we need here a semicolon. By syntax declarations of classes in C++ require that we provide a semicolon after the closing brace right here. So we're going to discover that when we put together the structure of our system, we typically discover various types of relationships between the classes. So for example, we can read the description of our use cases and find sentences that contain, for instance, something is because of something else.